All right, welcome to day 19, our review day. Everyone should have the review sheet. If not, it is in the class materials and then unit 2 if you go in there. It is in that folder. So here's your homework answers from yesterday. If you could pause the video, take the time to check each of your answers, and then I will pause for a second so you can pause the video on each of the worked out solutions if there's any that you need to check. So go ahead and pause the video right now and replay it when you are done checking your answers. Here's your answers to number 1. So again, you can pause the video right now if you needed to check through any of those. Here's the answers to 2, in case you had to check any of those. And here's the answer to 3. Couple things I want to talk about. In A, on the AP exam, if you're looking and you have at a table and you have to do a slope, so we need a rate of change of the velocity, which is the acceleration. If it's in between values in the table, you just use the values on either side. If it is at a value in the table, you can either use that value in the one before, that value in the one after, or the ones on either side. So because 32 is somewhere in between 30 and 35, we had to use those two values to do our slope. And then the other thing I just want to mention in D, you could have also worded it as the net change in the car's position. That's the same as saying the distance the car is displaced. So you can pause it here if you needed to check any of those. Okay, so a couple things to mention about the test. One, it's a calculator test. So anything where you have an integral, what I would expect to see, okay, you're not going to get something this easy, but let's say you had 2 to 3 of x squared dx. I would want to see on your paper 1/3 x cubed from 2 to 3, and then from there you could do your subbing in the calculator if you wanted. So you could sub in the 3, see what you get. So you get some number minus some number. You can do that all in the calculator from there. But I need to see the antiderivative first before you do subbing in the calculator. So we're going to do 3 of them together. And then the rest of the day, you should be working on the review sheet. And I would suggest come to office hours if you have questions on any of them. So we're going to do number 9 on the video. So this is our second fundamental theorem of calculus. When you've got from a variable to an algebraic expression and you want to take the derivative. Our capital F prime of x would just be the inside with the algebraic expression filled in. So this is going to be x squared cubed plus square root of x squared. But because we subbed in an x squared, we got to multiply by derivative of what we subbed in. Now, technically, you're always multiplying by the derivative of what you subbed in. Even if you subbed in an x, you're technically doing a times 1 afterwards. So if we neaten this up, this is going to be x to the 6th. And then the square root of x squared, remember, is absolute value of x. And then we've got times 2x. Well, to resolve that, that absolute value, we can look at the fact that from 1 to anything that's squared, it's going to be a positive. So that means our absolute value in this case will just be an x. When we distribute that through, we'll get 2x to the 7th plus 2x squared. Next one we're going to look at is 16. So we would want to do this with a u substitution. We'll let u equal 1 minus x. So du would equal negative 1 dx. So that's taken care of. That's going to be u to the half. This we need to multiply by negative 1. So negative 1 du is going to be dx. So that's taken care of. But we've got an extra x. So this is the situation where you go back to where your u was and get x by itself. So if I add the x over to the left, I'll have x plus u equals 1. Subtract the u over, and x is equal to 1 minus u. So now our integral, I'm going to throw my minus 1 out front. We're going to have a 1 minus u for the x. We'll have a u to the 1/2 from the square root of 1 minus x, and then du. We can distribute through. So we got u to the 1/2 minus u to the 3/2 du. And then this would be minus 1. We'll have 2/3 u to the 3/2. This will be u to the 5/2 with a minus 2/5 out front, plus c. I'm going to do two things. I'm going to distribute the negative through, and I'm going to fill in the 1 minus x for u. So we'll have negative 2/3. We'll have 1 minus x to the 3/2 plus 2/5, 1 minus x to the 5/2. And a negative 1 times a constant is still a constant. So you can just do plus c on the end. Now the problem is, the way that's written, it does not match any of the choices. So we shouldn't just jump to none of these. We should see if it neatens up at all. Probably not going to be D, because we don't have any negative exponents. But let's play around with it and see if we can get it to match any of those. So notice we have a 1 minus x to the 3/2 that we could pull out of each thing. So we'll have 1 minus x to the 3/2. That'll leave us with negative 2/3 in the first part, and that'll leave us with 2/5 times just a single 1 minus x for the second part. Well, bringing down the 1 minus x to the 3/2, I'm going to do two things. I'm going to distribute the 2/5, and also let's get a common denominator of 15. So this is minus 10/15. So really the 2/5 with the common denominator will be 6/15. So we'll have plus 6/15 minus 6/15 x. And we didn't necessarily need the minus 6/15 x because that's not going to combine. So this is going to be minus 4/15 minus 6/15 x plus c. But we can take a negative 2/15 out of each of those. So this will leave us with 2 plus 3x plus c. And now that matches one of our choices. It matches choice A. So that one can be kind of tricky to rearrange to get it to match one of the choices. Now, one thing you could always do, because it is a calculator test, when you got to the answer you got here, you could quick punch that in a graphs page and then plug each of the choices in a graphs page. Just don't put the plus c in, and you would know, okay, if the graph is the same shape but just shifted up or down, then it matches. Next one I want to look at is 23. So in 23, we can rewrite the original by pulling an x squared out. So we'll have a square root of x squared times square root of x squared plus 1 dx. And I think on yours, It should be added from 0 to 3. On the original problem, I didn't have that written in. So this becomes the integral of absolute value of x from 0 to 3 square root of x squared plus 1 dx. But because we're going from 0 to 3, absolute value of x is just x. Well, now we'll just do this with a u substitution. We can let u equal x squared plus 1. So du will equal 2x dx. This is going to be square root of u. That's good. Left over is x dx, so we got to multiply by a half to correct. So we will have 1/2 integral from 0 to 3. We're going to have u to the 1/2 and then du. Our antiderivative, or actually, let's change our bounds here from the 0 and 3 so that we won't have to sub back in for u afterwards. When we put u or 0 in for x squared plus 1, we get back 1. And when we put 3 in for x squared plus 1, we'll get back 10. That way we're not going to have to sub back in for u after. So we'll have 1/2, we'll have u to the 3/2 with a 2/3 out front. And we're going to go from 1 to 10 now. So that's going to be a 1/3 out front. We'll just have 10 to the 3/2 minus 1 to the 3/2, which is 1. And we can leave it right like that. So the last thing I wanted to mention was on question 32. We're not going to do it, I just wanted to talk about something. So when you are doing question 32, you should be finding actual areas when you go to plot the graph of g of x. So I think it would be helpful to make a t-table. It's very similar to what you did on the area function packet from this unit. Now, just like on the area function packet, make sure when you're sketching in your graph of g, it needs to have the proper concavity for each of the sections. All right, so you have the rest of the day to be working on the review sheet. Come to office hours with any questions that you may have.